This video talks about common mode gain. So in simplest terms, ACM, common mode gain, is how much the average of the output changes when the average of the input changes. So let's remember what the input is. So your VI plus is your VIC, so some offset, some value that VI plus moves around, plus some V in over 2, and VI minus is whatever that DC offset average of the input. VI minus is considered less by the same amount that VI plus is above VIC. Okay. And if you average these two, it equals the average of VI plus VI minus over 2. And if you add these two, then the VNs disappear because you have one plus VN and one minus VN. And you get 2 VIC over 2, which of course equals VIC. So the average of the input is whatever this offset is. It's that value that the input moves around. And just a reminder, when you're talking about a balanced input, you'll have VI plus, and then you'll have an equal and opposite signal, which is VI minus. And then the average of these two is your VIC. Okay. And then on the output, you can draw the exact same picture, except everything, instead of an I, it's an O. So it would look like actually, let's do it. It would look the same. And this is V out minus. This is V out plus. And then this average value right here. So if you added the two signals, this would be VOC. And the C stands for common mode. And common mode really just means average. Okay, so we've got all the terms defined here and the definition of ACM, but let's see what that means. So ACM is when you change the average of the inputs. How much does the average of the output change? So in other words, another way to say that, if you change VIC, how much does VOC change? Let's see what happens with this passively loaded differential pair. So first of all, let's set case VI plus equals VI minus. In that case, let's define an I1 and an I2. this case, I1 equals I2 equals ISS over 2. Okay, and if VI equals VI minus, if you take the average of that, okay, so let's come up with an equation for the output. So if these two are equal to each other, then V out plus equals V out minus. And it turns out what these equal is VCC minus ISS over 2, because that's the current going through both sides times the resistor. So there's going to be some voltage drop across the resistor caused by the current going through the resistor, and that current is ISS over 2. So now both of your outputs equal this. Okay, so then let's do. Actually, we don't really need a case here, but let's look at an example here. Let's say I see VI plus equals VI minus, and let's say that equals 2.5 volts. And let's say that causes a current of, say, 1 milliamp, and your resistor is 1K. Okay, so in this case, the average of your inputs, your VIC would equal 2.5, and your V out plus will equal your V out minus, which will equal, let's make VCC equal 5 volts. You'll have 5 volts minus 0.5 milliamps. Let's call this ISS. Milliamps times 1K, and that will equal 4.5 volts, if my math's okay. Okay, so then let's try it. Let's do something else here. Let's try a different case. Let's try VI plus equals VI minus, and let's set it to 2.6 volts. So in this case, since VI plus equals VI minus, VIC also equals 2.6. And sorry, let me add one thing here. Since both of the outputs equal 4.5 volts, because we have the same current going through both sides, then if you take the average of 4.5, it's just 4.5. So this is actually your VOC here. So let's try it with this. And the question is, what's your VOC? And it turns out nothing changes in this equation. You'll still have, if both inputs are the same, then the tail current source, which is ISS, will split between the two, and your VOC will just also be 4.5 volts for this. So when I change the average of the input, so I change the average of the input from 2.5 volts to 2.6 volts, the output didn't change. So let's look at the experimental equation for ACM. And I think that's all you need for the homework. We'll talk about the theoretical on Monday then. It's your ACM equals, you have, in this case, let's call this case 1 and case 2, you'd have your VIC1 minus your VIC2, and your VOC1 minus your VOC2. And in this case, if you plug in the values, you get 4.5 volts minus 4.5 volts. Then on the bottom, you've got 2.5 volts minus 2.6 volts, and that just equals 0. And the best ACM you can have is 0 volts. And all this is the definition. I'd like to give people an opportunity to ask questions, so I will talk about this a little bit more in class on Monday. I'll put one more video up, but I think this is all you need for the homework.